Hey Thomas Tutors, we're ready to move on to our next lesson for the week. Today we are going to subtract polynomials using visual diagrams. So let's take a look at what we already know about the topic. We already know that when we think about the operation of subtracting, we are taking away. That means that if we start with some quantity, we're going to lessen that quantity by taking things away. Let's take an example. With the equation 8 minus 6, I'm thinking, what if I represent those 8 objects and then take away 6 of them? So with my 8 circles, I'm going to now go ahead and cross out 6 of them. 1, 2, 3, 4, 5, 6. Once I take away 6, I notice that I have 2 left over that I haven't crossed out. So I know the answer is 8 minus 6 equals 2. Now I want you to keep in mind this number 2 and this idea of subtracting, taking away. And then thinking about what does that look like if we were thinking about subtracting as adding the opposite and creating 0 pairs when we add that opposite. We're going to take the same equation, 8 minus 6, and think about what does it mean to add the opposite when we're having subtraction. I'm going to rewrite this equation by adding positive and negative signs to show what these numbers or these integers really represent. So I have a positive 8, and I'm going to subtract a positive 6. That is just me writing the original equation. But now I wanted to get into this mindset of adding the opposite. So let's go ahead. I'm going to start by rewriting my positive 8. And I'm going to add the opposite by changing my minus sign into a plus sign. And the opposite of a positive 6 is then a negative 6. Let's go ahead and represent each of these numbers with their positive and negative signs. So I have 8 positives. So I'm going to draw 8 plus signs. And I'm going to represent my 6 negatives with 6 minus signs. And I'm then going to take my visual representation and create 0 pairs. What that means is for every plus sign I have, I can create a 0 by matching that up with a negative sign or a minus sign. So for every plus sign, I'm going to match it up with a negative sign until I have no pairs left. So let's go ahead and do 1 plus sign with another minus sign, 1 plus with a minus, plus with a minus, plus with a minus, plus with a minus, and plus with a minus. So each of these matched up positive and negative signs create a 0, and we know that 0 has no value. What we notice that we have left over is these 2 positive signs. So I'm going to write my answer as positive 2, which is the same answer that we got earlier, thinking of this operation as taking away. But I want you to get in the mindset of adding the opposite because it's very important when we're working with polynomials. So we already know when we were working with adding polynomials that we can only add together like terms. That means if I were to work with, say, x squared, I know that I can only combine x squared with, say, 2x squared. This is an okay combination. But say if I have x, I have 2x squared, and say I have 4x cubed. This is not okay because this has a degree of 1, a degree of 2, a degree of 3. These are not the same, so we cannot combine them. The same thing applies when we're subtracting polynomials. Let's go ahead and apply this to new ideas. What does it mean to subtract by adding the opposite when we have variable expressions or polynomials? Let's look at our polynomial here. We have 5x squared plus 8 minus 3x squared. So I see that there are an x squared and an x squared. So that means it's okay to combine these. So let's rewrite that as 5x squared plus 8. And since I'm adding the opposite, this negative is a negative 3x squared. Because I'm changing that minus sign into a positive sign, or an addition sign, and changing my positive 3x squared into a negative 3x squared. So I'm adding the opposite. So now that I have 5x squared and a negative x squared, I'm visualizing in my head. If I have 5 positive things and 3 negative things, how many do I have left? I only have 2 positives left. So I have 2x squared plus 8. That is how I simplified that expression. But let's see what this might look like if we're working with longer polynomials. For example, this problem here. Now, a common error that some scholars might make is that when they look at this problem, they realize that this negative sign, this minus sign, only applies to the first thing in the parentheses. So they might be 4x cubed minus 2x squared, or 4x cubed plus a negative 2x cubed. Might think answer, hey, it's 2x cubed. Then I might want to add 15x squared plus 6x squared equals 21x squared. Then there's nothing to work with the x, so that's plus 6x. And I have a positive 4 plus 4, and that's my final answer. This is incorrect. This is a no-no. Let's go ahead and try that problem again, thinking about the distributive property. So when I don't have anything in front of the parentheses, I can visualize that this is a negative 1. And when there's something in front of the parentheses, that means I'm using the distributive property to distribute to each term in the parentheses. And it already looks like this type of problem when we're subtracting polynomials is going to be a lot more difficult than adding polynomials. So let's go ahead and rewrite. Everything in front is going to be the same. This first polynomial is going to stay the same. But if I am going to add the opposite, let's go ahead and change that to a plus sign. The opposite of a positive 2x cubed is a negative 2x cubed. The opposite of a positive 6x squared is a negative 6x squared. Notice how I'm changing all signs to the opposite and connecting all these terms with a plus sign. So this negative, this minus sign, changed all the terms into the opposite. Now I'm using the word opposite rather than the word negative because signs can change differently, and I'm going to show you that a little bit later. So let's go ahead. 4, positive 4, and negative 2 is going to give us 2x cubed. Positive 15 and negative 6 is going to give us a positive 9x squared. There's nothing to do with the 6x, so I'm going to just rewrite it. And then I have a plus negative 4. So my answer is 2x squared, 2x cubed plus 9x squared plus 6x minus 4. So each of these, any of these answers, you can end it off with a plus minus 4 or just a minus 4, and both answers are correct. Now let's go ahead and take one more final problem and see what I mean by using the language of opposite rather than the language of negative. Let's try another problem. What if there are some terms inside the expression that already has a negative term. So look at, I have a negative term in here because I'm subtracting a 5x squared. And look, I already have a negative 2, there's a negative 5, a negative 2, and there's a negative 4. So I want to continue with this idea of adding the opposite. So let's go ahead and rewrite the entire equation. 6x cubed plus negative 5x squared plus x. Now this minus is going to be, pretend it's a negative 1 and you're distributing each sign to every term. So this is going to be a plus. Minus is the same thing as adding the opposite. So if I add something that's already negative, it's actually going to become positive. Because the negative sign changed into a positive sign, because the opposite of negative is positive. This started off as positive, so this is going to change into a negative. This started off as a negative, so this is going to change into a positive. So let's go ahead and combine like terms. A positive 6 with a positive 2 is going to give me 8x cubed. A negative 5 and a negative 6. How many negatives do I have? That's going to be a plus negative 11x squared. I have no x to work with, so I'm going to just rewrite that plus x. And I have plus 4. Now again, adding the opposite or adding this negative can also be rewritten as 8 cubed minus 11x squared plus x plus 4. Now let's see if you can give it a shot. How would we solve this problem? X to the 4 minus x squared plus 16x minus 9 minus the quantity of 2x cubed plus 3x squared plus 4x. Since it's a little tricky, I want to remind you of this side. This negative means that I want to add the opposite. And adding the opposite means that each of the signs inside are going to change. See what you come up with. Post in the comments.